Hello and welcome to ATG 4950. In this session, we will address product maintenance and reliability, their definition, importance, and the strategies that can be used to ensure a reliable product. Maintenance is defined as all activities involved in keeping a system's equipment in working order, while reliability is defined as the probability that a machine will function properly for a specified time. The objective of maintenance and reliability is to maintain the capability of the system while controlling costs. When buying any product, usually we look at the warranty associated with it or the possibility of buying a maintenance plan. But the maintenance and reliability is not only important for the customer, they're also important for companies. Maintenance and reliability can affect companies' operations. If one of the main machines broke in a manufacturing environment, the company's operation will be affected and employees might be idle until fixed. It will also affect reputation. If the reliability of the product or the maintenance are not good, that will affect the company's reputation, which will cause customer loss. It will affect also profitability. So the operations has been affected, which caused a customer loss that will lead to the decrease of profit, or maybe the profits become losses. At the end, all that will lead to customer dissatisfaction. So what are the tactics that can be followed to ensure better reliability and less maintenance? For reliability, we have two tactics, which is improving individual components and providing redundancy. When we say improving individual components, means increasing the reliability of these components, which will lead to the increase in the reliability of the overall product components. When we say providing redundancy or having parts ready to replace existing parts in case of failure, that means we can replace the parts as soon as they fail. And that will be explained in later slides. For the maintenance, we have two strategies or two tactics. First, creating a preventive maintenance plan that can be implemented before the machine breaks down, and the other one is to increase repair capability or speed, and that will also be addressed in later slides in details. For the maintenance strategy, we usually like to get the company's employee involved through information sharing, skill training, reward system, employee empowerment, and we can also create maintenance and reliability procedure, or we should create a maintenance and reliability procedure which will emphasize on cleaning and lubricating the equipment, monitoring and adjusting those equipments, make minor repair, and keep computerized records. And the purpose of that is to this strategy can be implemented on the organization level, which will maintain a continuous production with a reliable product, which lead or result reduction of inventory, improved in the quality of the product, improved in the capacity, a reputation for quality, continuous improvement, and will reduce the variability in product. So let's go over these tactics in details. The first one we stated was improving individual components. To understand, let's look at the way it works. The total product reliability, which is in this case RS, will equal to the multiplication of reliabilities of the individual parts, R1, R2, all the way until Rn. The overall system reliability will actually decrease when you have more components. So the more components we have, the more the component reliability might affect the total reliability. For example, having n equal to 1, which means one component, the reliability of the system will decrease with the decrease of the reliability of that component. In this case, you can see that the average reliability of the component in percentage, which is 100%, will make the reliability of the system at 100%. The decrease of that component will decrease the quality of the system or the reliability of the system. Having 10 components will decrease it more, 50 components more, and 400 components. You can see the decline in the reliability of having 400 components. How does that work? Let's look at the slide. If we look at this example, we have a process or a product that has 3 components with reliabilities of 0.9, 0.8, and 0.99, or 0.90, 0.80, and 0.99. Let's calculate the RS for this system. So the overall reliability will equal to R1 times R2 times R3, which will lead to overall reliability of 0.713 or 71.3%. And that's the overall reliability of the system. So having 3 components decreased the reliability tremendously from the range of 90s or 80s all the way to range of 70s. And that's what we're talking about in the graph. To calculate product failure rate by percent, we divide the number of failures by the number of units tested, then multiply by 100. To calculate the failure rate by number, we define the number of failures by the number of unit hours of operating time. From that, actually, we can calculate the mean time between failures, which will equal to 1 over failure rate, which is the one that we just calculated in this step. To understand more, we go over an example. In this example, we have 20 air conditioning units designed for use in the NASA Space Shuttle, operated for 1,000 hours, which means that the total number of hours that those machines should operate is 20 times 1,000, and that equals to 20,000 total hours. One failed after 200 hours and the other failed after 600 hours, which means that those two operated only 800 hours instead of the total of 2,000 hours. So I was assuming that all machines will operate for 20,000, but actually 2 machines failed, so I have to subtract the time that they did not work, they did not operate, which is in this case 1,200. And that is the difference of hours that need to be subtracted from the 20,000 to get the actual unit hours of operations. Based on that, we can calculate the failure rate as a percentage, which will be 2 divided by 20. We have 2 failures out of 20 machines, and multiplied by 100, which is equal to 10%. If we would like to calculate the failure based on the number of operation hours, that will equal to 2 over 20,000 minus 1,200, and the 1,200, we said that those are the hours that the machines did not operate, which will equal to 0.000106. The mean time between failures will equal to 1 over the 0.000106, which will equal to 9,434 hours. So the failure rate per trip will equal to the failure rate that we calculated multiplied by 24 hours multiplied by 6 days per trip, and that will equal to 0.153 failures per trip. When we provide a backup component, we can actually increase reliability. So the reliability in this case will equal to probability of the first component working plus the probability of the second component working times probability of needing that second component, which will equal in this case to 0.96. Multiplying by 100, it will be 0.96%. So it will be a reliability of 96% or 0.96 for that component, just by having a second component standby. If we go back to the previous example of reliability and added replacement parts, means using redundancy strategy, then the overall reliability will increase from 71.3% to using the calculation 90.94 or 94%. So from 71.3% to 94%, or from 0.713 to 0.94 of reliability. Going back to maintenance, we notice that we have 2 types of maintenance. Preventive maintenance, which is routine inspection and servicing to keep facilities in good repair, and breakdown maintenance, which is an emergency or priority repairs on failed equipment. Implementing preventive maintenance in a manufacturing or on the organization level, we need to know when a system requires service or is likely to fail, and create a schedule to maintain the system. High initial failure rates are known as infant mortality, which will affect the production and will increase the cost and reduce the profitability. Actually, it can lead to a total organizational failure. Once a product settles in, the mean time between failures generally follows a normal distribution. Good reporting and record keeping as historical data can aid the decision in the decision making or in the decision on when preventive maintenance should be performed. But at the same time, we can create a preventive maintenance plan and provide that as a documentation with the individual product. We can actually include that in the user manual or as a separate document. So we are not talking only about maintenance for the machines in manufacturing or in the organization, but we are also talking about product that we just created or we created during the semester, and we can create a maintenance plan, recommend a maintenance plan for the customer, and include that in the documentation, the user manual, or a separate document for that. Currently, and with the new technology, most companies use or are using a computerized maintenance system. The system will have data that includes equipment file with parts list, maintenance and work orders schedule, repair history, inventory of spare parts, personal data or personnel data with skills, wages, and other related information. This system can provide reports, lists, work orders, and cost analysis, which will aid in taking the proper decision and developing the proper strategy or plan for maintenance. Usually, operations manager attempt to balance preventive and breakdown maintenance cost, but sometimes they fail to consider the true total cost of breakdowns, which will include the cost of inventory, employee morale, and schedule unreliability. This chart shows the total cost line based on a preventive maintenance cost and a breakdown maintenance cost. By increasing the preventive maintenance, we decrease the breakdown maintenance, which at a certain point will be its lowest value, then start increasing again. So even with the preventive maintenance, we have to be careful not to exceed the limit, otherwise it will affect the total cost. And that is from a traditional point of view. But if we look at it from the actual point of view, with all the factors, it will provide the real picture and the full cost view, and we can see the optimal point of cost of the lowest cost maintenance policy. Let's look at an example. A company that would like to have printing capabilities, but they don't know if they need to contract someone for maintenance on their printers. Should they? They looked at the number of breakdowns at and at the number of months that breakdowns occurred, and they got that table shown in this slide. The average cost of breakdown is $300. So for zero number of breakdowns, we have 2. For 1, we have 8. For 2, we have 6. And for 3, we have 4. So we have total of 20 number of months that breakdowns occurred. First, we compute the expected number of breakdowns by finding the frequency, then multiplying that by the number of breakdowns, then finding the sum for the incidence, which will equal to 1.6 breakdowns per month in this case. Again, 2 out of 20, that's 0.1 frequency. 8 out of 20, that's 0.4. 6 out of 20, that's 0.3. And 4 out of 20, that's 0.2. And multiply that by the number of breakdowns, we found that the average is 1.6 breakdowns per month. The next step will be to compute the expected breakdown cost per month with no preventive maintenance, which will equal to expected number of breakdowns multiplied by the cost per breakdown, and that will equal to $480 per month. Now we compute the cost of preventive maintenance. which will equal to the cost of expected breakdowns of service contract if service contract signed, plus the cost of the service contract itself, which will equal to 300 plus 150, and that's $450. Compared to the $480, the decision should be to hire a service firm to maintain the machines. The other strategy is to increase repair capabilities, and to do that, we need well-trained personnel, adequate resources, ability to establish repair plan and priorities, ability and authority to do material planning, ability to identify the cause of breakdowns, and the ability to design a way to extend the mean time breakdown or between failures. This figure shows how maintenance is performed, where you can see the preventive maintenance costs less and is faster, moving to the left, while competence gets higher if we move to the right. Total productive maintenance is a method for improved machine availability through better utilization of maintenance and production resources, which was introduced in Japan in 1971. This method includes designing machines that are reliable, easy to operate, and easy to maintain, in addition to emphasizing total cost of ownership when purchasing machines, so that service and maintenance are included in the cost. Then developing preventive maintenance plans that utilize the best practices of operators, maintenance departments, and depot services or service. Then training workers to operate and maintain their own machines. We can also establish maintenance policies using simulation and expert systems to analyze complex situations, model different maintenance programs, and select the proper model that fits our needs with the lowest cost. And utilizing computers and computerized systems to identify problems and select the proper course of actions. That will be all for this session. If you have any questions, please email it to me through Florida Online. Thank you and have a great day.